bit of an impromptu video, but I've just been going through some stuff and I found my coal samples, and in them I found something really interesting, very cool, something you don't see much at all. Now, in tropical environments, just as it would be in Carboniferous age, you find, see if we can get this to focus, large areas with upwelling springs, and on the water on top of those springs you find a fine, almost silvery sheen. And it looks a little bit like oil, but it's not. It doesn't like have that rainbow effect like oil does. And what it is iron bacteria. So deep down in the spring, there's all these bacteria feeding on the plant remains, all the sort of peaty, almost peat-like stuff that's down there, and the bubbles they produce of carbon dioxide actually percolate through the substrate and make it very soft. Now you can see that here in this coal because it's very, very fine. It's almost like, well, it's so fine it's shiny. And that's just broken coal. It's not, I haven't done anything to it. And you can see here that little, focus, that little iron nodule right there in the middle, that rusty bit. That's literally an iron bacteria nodule that's 350 million years old. I'll show you, move across to this one, and there's some more. Now this bit actually is not a particularly not a particularly dense population either. Come on phone, do your stuff. There we go. Now, if I come across to this piece here, see it's really clean, really pretty shiny stuff, very dense coal. But if I turn it over, you'll notice halfway through it changes. And on the other side, literally within half a centimetre, it changes from normal coal to one of these iron bacteria wells, and it is absolutely riddled with iron nodules. I can tell you from experience, if you ever go near a marsh or a bog, peaty area, and you see water on top of that stuff with that sheen on it, don't step in it, because it can be meters deep, several meters even. And I once actually stepped on a piece of what I thought was just moss, and I disappeared like waist deep on one leg into the peaty wet. There wasn't anything under my foot, and if I'd gone in both feet I would just have vanished. But yeah, there you go. Iron bacteria producing carbon dioxide and what's called bivalent iron. Now, bivalent iron is really important to plants because it's what chlorophyll, part of what chlorophyll is made of. The plants need iron and other trace elements to live, but iron particularly is really important. So when you find areas like this in rivers, you get then large populations of plants and even bigger populations of fish, because there's carbon dioxide in the water. There's also a lot of oxygen from the plants, but the carbon dioxide is what makes that all possible. So if anybody ever says that carbon dioxide hurts fish, it doesn't. Not all fish. Trout, don't do well with it. But some fish can take up to, well, 0.5 gram of carbon dioxide dissolved in water per litre. That makes it very, very acid and very soft water. Just imagine 350 million years ago, this lot munching away and practically fizzing with carbon dioxide. And that's all locked away in there now, because this coal, of course, is almost pure carbon. Almost. There's lots of lignin in there as well. Lots of, well, because there were no mushrooms, it's basically tree. It's compressed and squished tree, which is why you can find lots and lots of interesting fossils in there as well. Bit of rambling, but hopefully you found that interesting.